All right, here we go. This is, let's see, section 2.5. Okay, fill in the blanks. If f prime is positive on an interval, then if f double prime is positive, then f prime is increasing on that interval. And f is, well, let's take a look at the picture because I don't think I said this tonight in class, and so we'll touch on it on Wednesday. But if f double prime is positive, then f prime is increasing. So that looks like something in that shape, or even this shape, because f prime is certainly increasing because it's very negative, less negative, less negative, so it's actually getting bigger. So a curve where f double prime is positive, that's a curve that is of this shape, and we call that shape concave up. So we're going to say that's concave up. Sorry I didn't hit on that tonight. If f prime is negative, f double prime is negative, then f prime is decreasing. So second derivative is negative, it's going to be going down like that, or like that kind of thing. And f is concave down. So that's f double prime is negative. So we'll see concave down. All right, number 2. For the function graphed in 248, are the following non-zero quantities positive or negative? So f of 2 is that point right there. Oops. Not sure why I'm not drawing on there. So f of 2 is that point there. So that's going to be negative because the y value is negative. F prime is the slope of the tangent, which is negative. What's second derivative? Well, second derivative, what's happening to the slopes? The slopes are actually increasing in that range. The graph is concave up, which shows that graphically. So f double prime is positive. Okay, I'm going to erase that. At one of the labeled points on the graph of this figure, both dy dx and second derivative are positive at one of the points. Well, let's look at it. Here it's curved down. The derivative is decreasing, so it's concave down, so the second derivative is negative at 2. The second derivative is positive, like we said, but this derivative is negative. At 4, the derivative is positive, and it's increasing, right? That's concave up. So they are both positive when x equals 4. I just did it on the wrong graph, it looks like, now that I see it. That's 249. Well, I just did that on here, so look at that graph and see if that makes sense to you. But let's do the same thing here. Here the slope's negative, and the second derivative is positive. Slope's positive, second derivative is positive, so that would be b. C, it's positive. The second derivative is negative at c, d, and e. Okay, because it's the slope is getting smaller, that whole thing, and graphically it's concave down. But c is the only one where it's, or actually, c it's positive, d it's 0, e it's negative slope. So b would be the only one where they're both positive. So there's a twofer right there. All right, number 4. At exactly 2 of the labeled points here, the derivative f prime is 0, and the second derivative is not 0. On a copy of the table, give the signs at each marked point. Okay, so since they said the derivative f prime is 0 at exactly 2, so that's going to be at a and b. So f prime is 0, 0. At c, f prime is negative, and d it's positive. And the function values, a is, we're going to go negative, b is positive, c is positive, and d is negative. Second derivative, it's concave up here, so f double prime of x is positive, means it's concave up. I'm just repeating myself here from earlier as well, which means it's going like that, like we talked in class we hit these two things, we just didn't use those words there. So f double prime at A is positive, at B and C it's negative, and at D it's positive because it's concave up there, but also the real reason is because the derivatives are getting bigger and bigger. They're increasing. Okay, because we said this also means that f prime of x is increasing, meaning getting bigger. Number 5. Graph the functions in parts A through D. So A, first derivative and second derivatives are everywhere positive. So it's going to be something like this. Right? B, okay, because the first derivative is positive means slopes are positive and it's concave up. Second derivative is negative, the first derivative is positive. Right? Derivatives are positive, the slope's positive, but it's the first derivative is decreasing, and so that means the second derivative is negative, concave down. C, second derivative is positive, first derivative is negative. Oops, so it'll be like this. Get rid of that guy. So that'd be C, second derivative is positive, so it's concave up, and the first derivative is negative, and D. And sorry about that pause. First and second derivatives are both negative, concave down. So the second derivative is negative, and we've got, look at the slope. Slopes are all negative, and they're getting smaller. So bottom line, f double prime positive means f prime is increasing, which means it's f prime increasing is concave up. F double prime negative, f prime decreasing, concave down. There we go. Number 6. Sketch a graph of a function whose first derivative is everywhere negative and whose second derivative is positive. Oh, and whose second derivative is positive for some and negative for others. But the first derivative is everywhere negative. So like that. So from this point to this point, we have f double prime is negative, f prime negative, f double prime positive, f prime negative. Okay, really get a good handle on that, and that will do you well as we move through the course. Sketch a graph of the height of a particle against time if velocity is positive and acceleration is negative. So sketch the height. So the first derivative is velocity, so its velocity is positive, and acceleration is negative, so it's got to be like this. Right, where this is t and this is position, so say it starts right down here. So here, the velocity is the slope, which is positive, but the acceleration, which is the second derivative, is negative because it's decreasing. The slope, the velocity is getting smaller and smaller. All right, there's the first handful.